Yes, sir.
Yes, Rajpal sir, over to you.
Good morning, everyone. Welcome, Shweta ma'am, Dr. Akash, Venkat, and whole team of IHFC. First of all, thank you very much for giving me this opportunity to interact with all of you on this event. I can recall the very first day when this DRL was launched in my school, and when Dr. Saha and our Director Education they launched this league, at that time it was a big event for us, and still we are carrying over with the same spirit. The very first time when in Tyagaraja Stadium, the event of this type happened, and we told our children that this time we are going there, like an say the observer, or just we have to see how it is happening. But next time we should be well prepared, and we should be there like a we will be participating in that. So this year we are preparing hard to compete there, to participate there, and with all one part of all SOSC students, those who are preparing for this, mainly the students for STEM and high-end 21st century skill students. You know, field is a new one for us, and most of the children they are exposing very first time of this type of event, and it's a big responsibility on our shoulders to carry this forward with the same enthusiasm, and they should know all ups and lows of all how to prepare all this type of robot and how to compete in this event. And I wish, and I'm sure this is going to be every year it is going to happen, and permanently when any event takes permanently year to year basis, then it's always an inspiration for all participants that this year maybe they may not achieve targets what they have set it in their mind, but next time they prepare well because they know that next year it is going to be happen again. So when they come back with a commitment, then next time we will be more serious, we will be a more tough competitor. So my wishes are there. I say good luck to all participants, those who are attending today's orientation program for this league. Try your best, and participation is the important one. It's nonetheless whether you win this particular event or you don't win it, but participation, the experience you get in all this event, that is more important. So I wish you all the best. I again welcome ma'am for giving us the valuable time for it, and definitely Venkat sir, your hard and untiring effort is there behind of all this. Dr. Akash, thanks a lot for supporting us, our students in all this, and we hope next year, as again we have been re rescheduled all of this schedule with all of you, and you all people will be with us for next year also. So I hope these children will be getting some sort type of exposure which is happening very first time in their life. And even though I don't think in Delhi any such league has happened earlier, so it's a new experience for us and for you people also, because with the school I think you are organizing the very first event of this type. So I wish you a
Sure.
great success for it, and I wish success to all the participants. Uh, thank you. Thank you very much.
Thank you, Rajpal sir. Thank you, Rajpal sir. We much appreciate. With and on that, you giving us a go ahead. Thank you. I'm pleased to invite Miss Shweta Bajpai being with us. Your passion to kind of associate with the students is evident from your engagement in STEM schools. You have visited STEM schools in SOSC, and it is our pleasure and honor to have you here in person to kind of speak with the participants who are eager to build their robots, but they have to balance it out. Their exams are around the corner, and this competition will happen in July. So I'm sure ki with your words of inspiration, these teams will be going ahead full force once they are done with the exam. So over to you, Shweta ma'am. May we request you to turn on your camera? Thank you.
Are you able to see me, Akash?
Just
Or
now.
it's still not visible? Because the camera is on from my side. I'm not sure whether.
Just a moment, ma'am. We are
Sure.
spotlight for everyone. We have put you on spotlight. So camera is not working.
It's not working.
Can you your camera? Yeah. You can try once again, turning off the camera and turning it back on.
Let me try to do that.
And Dr. Venkat,
Yes.
if there is a possibility of making ma'am a presenter.
Right. She is already a
I
presenter.
think I'm already a presenter. Yeah, but for some reason the camera is not working. I know you are on a tight schedule, so let's not get the tech to come between us. Let me get
Yes.
started, irrespective. Thank you so much, Akash, Dr. Venkat, and Mr. Singh for the invitation and the introduction to an event like this. Just for introduction for everyone, I work at Meta, and I've worked in Google before this. I'm an engineer by training, and really look at encouraging and developing the next generation of students who can be part of shaping technology for the future. I've been associated, at least from a inspiration perspective, with the STEM schools for a while. I've kind of always felt that what the STEM schools are trying to do for Delhi specifically is a very unique goal, and which is why I loved the invitation when Akash shared the same with me. I know the Robotics League is a very unique event, and what it tries to do for all of you is get you all into teams where you can kind of work with each other to build robots which solve a practical problem, like a real world problem or an interesting, ambiguous problem for which the solution is not known. While exams are, I think, on your mind, and it's very important to do well in the exams, do keep in mind that a lot of what technology careers kind of look for, or how you build your profession in the future, is very much dependent on how you understand real world problems. So for example, if there is a real world issue that you are trying to solve, I saw the presentation that Dr. Venkat shared some time back, which was a gaming problem. There could be a gaming problem, or there could be a simple problem around, let's say, manufacturing operations, and you're trying to build a robot to address that. That is a skill that is totally valuable. Like, no matter which career you pursue, whether you sit for companies or whether you're looking for a profession, this is something that will always come into use. And apart from that, how you work together in teams. When you're working in a team, everyone is good at something. There is no one who is good at everything. So I think the art of balancing that out, knowing how do you leverage upon each other and get ideas from each other to build something which is really valuable, really unique. I think that is where you should focus your attention. I think, as Mr. Rajpal also said, winning or losing is not really important, and that's not why you're doing this. You're doing this for a really practical experience to what science and technology as a career or as a way of, let's say, doing your work could really look like. So do enjoy the competition. It's an amazing opportunity, and a huge call out to everyone who's tried to make this possible. Really looking forward to how the competition shapes up. And do make the most use of it in your careers and how you basically think about your journey in the future. Thank you.
Thank you very much, Ms. Bajpai. It's a pleasure, and it's a double pleasure, or rather, a pleasure plus for me, because both of us studied in the same alma mater, IIT Kanpur. It instilled in me, and I'm sure I think it gave us sufficient opportunities to explore beyond academics. Whether it was the alumni reunions which inspired us, and the Tech Fest of IIT, the Tech Riti. So I think I have so many things to reflect back, and I relate to what you are saying. But team, when you mentioned about team, that everybody has its own capabilities, everybody is strong in something. So I'm sure with your words of wisdom, the teams will work together and they will achieve more. As we always say in simple way, together everyone achieves more. So thank you very much for your time. I know you have a very busy schedule, and on Sunday with family time, but I think it was our honor and pleasure to have you here and hear from you. Students will look forward to Meta and many other works, great works being done at by your team, and take inspiration from that. I want to say a sincere thank you on behalf of Delhi Robotics League Planning and Execution team. Thank you.
Thank you, Akash. Thank you, Dr. Venkat. Best of
Wish you a
luck,
good day.
everyone.
Thank you. over to you, Dr. Venkat. And I know Dr. Venkat has a technical panel with him, which is going to focus on the submission, stage 1 submissions, and also he has some announcements to make about the timelines, considering your exams, the stage 1 submission timeline. So over to you, Dr. Venkat and team. And thank you.
Yeah, thank you very much. Thank you, Dr. Rajpal, and thank you, Ms. Sweta, for your welcoming and inspiring words to the students and participants, especially here. So let me go through the website so that so if people are aware that the deadline for stage 1 submission is up to April 7th. And for the main event, we have around 122 days left. And let me go to the dates so that we started off 16 December, the launch at Suraj Malvihar School of Specialized Excellence, where Dr. Rajpal, our guest of honor, heads. We have on several requests, we have extended the deadline for DRL registration. Now, due to exam season, stage 1 submission as well. And one important thing I wanted to announce is that who have already submitted, they can again rework and they can resubmit their total work proposal. Okay, on 21st, we are anticipating to give the result on 21st, but the main event dates will not be, hopefully they will not be shifted. Okay, and as well the stage 2. We are also planning for some boot camps. We are making a plan. Let us see how they will work out. We are still in the planning phase. Once they are ready, we'll announce on appropriate stage and this thing. So another thing I wanted to discuss is game rules. So we have recently updated the game rule book. Kindly go through that. And we also forwarded the registration forms to your individual emails. Kindly go through them. And the form is pretty simple. It asks about your details and it asks how you're designing that. So our team, they'll be discussing about in detail, giving you suggestions how to go through with these mechanical and electrical, electronics and computing tools, which one to select, when to select, how to select them. And these are some of the evaluation criteria. You might have gone through that. And moreover, Delhi Robotics League competition, there is no entry fee and it is totally non-paid gaming platform for all the Delhi kids. And one more thing I wanted to make it clear here is that it's a game actually. So let me unshare. What is a game? So can any please use the chat box to answer this. So game or what is meant by a competition in general? Please use the chat box to answer. Hope you can hear me. To know where you stand. One response has come, to know where you stand. Anything else? Competition means learning. This is very good. Competition means learning. Okay. So this is more specific to this game. Our game is to shoot the concha competition means meant for recreation in a learning way. This is also very good. Form of play. Oh, many answers are coming up. Let me open the chat box directly. Yeah, it is good to see everyone responding. And I wanted to ask, what do you mean by sportsmanship or sporting spirit? What do you mean by sportsmanship and or sporting spirit? Fair play. That's really good. Yes. Okay. I'm pretty much happy that you are giving very good answers, that you are aware of how a game or a competition should be played, and how what is meant by sporting spirit. So here, this is an opportunity, as our guests have given their opinion, that this is a very good opportunity for every one of us to learn in an experiential way, as well as learn from our team members, as well as learn from our opponent teams as well, admire their way of skill they're presenting. Okay, so let us take it forward, and we'll see how these Suraj will explain about the mechanical concepts, and Ms. Mridmay will be helping out, and let us have a discussion on several queries you have, and make this Delhi Robotics League a big success. Okay, so it is over to Mr. Suraj. Suraj?
Yeah, I'll just share my.
Yeah, welcome, Mr. Suraj. Mr. Suraj is a PhD student at, of course, he just submitted, and in few months he will be a doctor. He will be Dr. Suraj. He is a PhD student at IIT Delhi in mechanical engineering, and he specializes in mechanisms and robotic topics. Yeah, it's all yours, Mr. Suraj.
Yeah, I hope the screen is visible and I'm audible.
Yes.
Okay. So I think I request all the attendees to lower their hand right now. We don't want your hands to get hurt. You also have to build robots.
Yeah.
So I'll be giving an overview of mechanical concepts required to move forward in this competition, and how to select different components, and how to design your robot overall. We'll be just covering these topics. It will be more of a technical overview. So initially we'll see wheel selection, then different materials, and some basic introduction to mechanisms. And we'll also see some of the tools which you can use to develop your CAD and 3D models. So like some of you, the students who have already gone through the taster courses in robotics and automation, they have some brief idea, and others also, I hope you have some basic idea. We'll be just elaborating on this. So coming to wheels, like these are the most important parts of your robot. As you know, the video Dr. Venkat shared, you see the bots moving around, and this is where the most of your robot control and robot, how it moves, and how you stop the robot, and how you move the robot to your desired place, that comes into play. So we'll see some different types of wheels which are commonly used in robotics. We'll see four different types. So the first one, as you can see in the left hand side, is mm, So yeah, this is a standard wheel. This moves in a fixed direction, and you can connect this to your motors, and it is just a fixed wheel where it only moves in a single direction of the motor which you are driving the robot. So this is standard wheel. The second one is a caster wheel. Again, this cannot be driven. You cannot fix this to your motor, but this is just a support. You can, if you observed some of the swivel chairs, you have these kind of wheels which rotate in any direction. So this is just a support wheel to orient your robot. Okay, next, we have these multi-directional wheels which you can use in your robot. This is on the left. You see, this is a omni wheel. This has a perpendicular, like this has a primary direction of motion, and again it has perpendicular rollers attached to these wheels. That means it can support motion in both the directions. So you can use multiple omni wheels, and you can move your robot around without having the requirement for a steering or so. Similar to Omni, we have a mechanism wheel where these rollers here, they are oriented in different directions. Again, this is multi-directional rollers, and you can use these wheels to move around your robot smoothly. I'll just show some videos how these works. Like this is the first one. On the left hand side, you can see it has two standard wheels and a caster attached to this. So just by varying the speeds of the wheels in these two motors, you can just rotate your robot anywhere. Whereas in this case, in Omni wheel, uh, this can move in any direction based on, again, the input to your motors. You don't have like all three wheels here, they are driven. So in the form as well, you have this drivetrain, an option where you can choose how many wheels you have and how many of them are powered. That you'll have to explain. So coming to the next slide, we have again, this is again a video of a mechanism wheel similar to Omni wheel, but this is more smoother. You can see this is driven again on all four wheels, and it can rotate and turn in any direction based on the input of your motors. Okay, so this was about different wheels that you can use to build your robot, and on that you and your teammates along. Yeah, you and your teammates along with your mentor, you can decide on different wheels that can be used. Coming to second topic, there are different materials, and this again is also important on how you build your robots and what kind of materials you're planning to use to build these robots. I have again a few slides demonstrating different materials. So the first one is a basic MDF board. You must have used this. You must have seen this for basic robots, like when you're planning to build initial prototypes. This is very helpful. Like it is simple and it is cheap, and you can also easily laser cut these parts based on your requirement and then test out your prototypes. So this material is recommended for initial prototyping when you are just in the testing phase of your robot concepts, like how we are planning to give the form to your robot and what kind of shape, what is the size. So to determine that, you can use this material. Next again is acrylic. Again, acrylic can be used for prototyping robots itself. So compared to MDF, this has a bit higher capacity of load carrying, as well as this is water resistant and more durable than MDF. And coming to the main materials, we have metals, which are heavy duty. So basically for bots which are outdoors, and when you use this for competitions where there are a lot of contacts and impacts on the robot, then you use metals. So again, aluminium again is a common material used to build robot. This is very lightweight, durable, but however, it is slightly expensive, and but you get these frames ready-made on outside as well. You can make these custom sizes for your robots to build your bots. Next is steel. So steel is slightly cheaper, than aluminum. It has better strength, but main thing here is it is very difficult to machine. You'll need to have high-end machineries to cut these parts and to join these to build your bots. So again, you'll have to keep in mind what kind of material you are choosing for your robot during your initial stages of your design itself. So this, I'll just give a brief about mechanisms. There are different tasks which you have to perform in your RoboCancha. So mechanism is basically something that you convert motion from one form to another form. For example, you can see this here, the linear up-down motion is being converted to a swing kind of motion. So basically you have three different tasks if you see in the video as well as the rule book. Initially you have the ball shooting, then you have ball pushing, again you have to push the discs. So for these three tasks, you'll have to either use your whole robot as a individual body and then make these operations, or else you can also use different mechanisms. For example, for a ball shooting, I can show you here. This is a mechanism to aim your ball. Like you can adjust where do you want the ball to fly in which direction. So this is a example mechanism where you can use different parts and then build this. And here you can see a sample video of shooting where there's a disc here, a rolling disc, and again it is shooting to one particular target. So this is just an example which I'm sharing with you guys. You can I'm sure you have better ideas and different concepts which you're currently working on to realize this. Then there's ball pushing and disc pushing, which the robot with the body itself it can do. And even here, if you want to try mechanism, there's again a sample mechanism I'm showing where it is gripping the disc or the ball. So you can incorporate these kinds of mechanisms as well in your robot, where you have a better control over the discs or the ball, and then you can move the whole bot itself to your target area. Coming to transmission, we have all of you have seen gears. So gears are used for motion power transmission, and most of you, I think, are using electric motors, which have a fixed speed and torque. So in order to modify that, based on your requirement, you can use gears or gate trains. So a set of gears is called a gear train, and this where you made two gears, that is called meshing. So there are different terminologies for a gear. One of the most important is called a module. So module is basically the diameter of the gear divided by the number of teeth on this gear. So if you want to mesh two gears, you have to make sure that the module is same. For example, two gears have a same module like 1.5 or 2. So these are the things you have to keep in mind while choosing a gear for your system, designing this gear for your system. Okay. So next thing is gear ratio. Like you're converting a speed of the motor. Suppose a motor has some 1000 RPM and you want to convert it to a different RPM. RPM, I hope all of you know, is revolutions per minute. That is how the speed of a motor is measured. So gear ratio is basically the number of teeth in the output gear by input gear. So we have this standard law here where T2 by T1, if it is the number of teeth, is equal to N1 by N2, that is the speed of the in RPM, and then which is also equal to tau 2 by tau 1. So this is the torque required. So again, I'm not going deep into the concepts of torque or force. You can, I hope you already know by now. You need to measure the required torque that the motor has to provide to your system, and based on that you can select these gears as well. So there's an inbuilt in-house built tool we have from IT Delhi, which is called Mechanalyzer, where you can explore different mechanisms which you can try out and you can play around. This is a free software you can download from mechanalyzer.com. This will help you play around with different mechanisms, and you can just get some idea as to what kind of mechanisms you can incorporate in your systems. Also, there's a gear meshing tool where you can just select different gears which you can use in your system, in your robot. So final part, we'll see about CAD and 3D modeling. Some of the entries which you've seen, they have already used CAD 3D modeling. However, some have used simple sketching. So we recommend that you use these professional tools which are available. I'll just there's a few software, 3D modeling software which are free. For example, Tinkercad. Many of you have already used. This is a basic tool where you can model your bots, 3D modeling. There's also Autodesk Inventor. So with your if you have a student ID and in the Autodesk website, you can search for your school name. For example, SOSE schools, they have already been listed in the Autodesk, or you can also contact your IT coordinator in your school to get your school listed. So you can download this student version of Autodesk Inventor and you can build your models there. There's also one more tool called Creo. This also has a free student version. Then there's SolidWorks, but this is a licensed software. So if your school has license for this software, you can make use of it. And there's also a rendering software where you can build your model and then simulate it in some environment. There's a tool called Blender. We'll just go through about 2 or 3 of these. So Tinkercad is very simple and easy to use. It's a basic minimalistic software. Now, this is an online tool. You don't have to download it as well. So, and you can build your models here. You can also, if you want to do your initial prototyping, for example, you want to 3D print, or you also can laser use these files to laser cut on an MDF or acrylic sheet. But the limitation here is it can only create 3D models. For example, if you're working on metals, you'll need 2D drawings of that in order to manufacture or machine those parts. So that cannot be done in Tinkercad. It can only create 3D models for representation. Okay, this is, however, a professional tool, Autodesk Inventor, which thankfully has a student version where you can build different mechanisms. You can also build your whole robot in this. So you can also move the parts around and see how the parts are interacting with each other. You can animate the motion. Moreover, this can also create 2D drawings, which you can then use to build these parts if you're using in metal. So this was the tools. There are also other tools, other software, Creo. Creo also has a free student version. SolidWorks, as I said, is a licensed, and this is again Blender, which you can use for 3D modeling as well as for rendering your robots. Okay, so this was about the overview of mechanical concepts. If you have any questions, you can put out in the Q&A section, and we'll be answering it at the end of this session. Thank you.
Yeah, thank you very much, Suraj. We'll be coming back for questions, and I request Mrinmay to come up with the next one as well. Then we can have a very brief one-on-one Q&A.
Yeah, thank you, sir. So,
yes.
Good morning to all. I'm sharing my screen. Am I audible to everyone? Hello?
Yes, you are.
Okay, sir. My screen is visible?
Yes.
Okay. So, very good morning to everyone and all the participants over here. So today I'm going to speak on the electronics and computing concepts which you can use while building a robot. So to start with, I have like controllers, actuators, and sensors to speak about. So the first thing is many of you are already aware of what is a controller. Like we can to control your robots and very other things we use controller. So controller is a hardware device or software program that manages or directs the flow of actions between two entities. So here today I will be speaking about three of them, like Arduino Uno, Raspberry Pi, Node MCU. So what is an Arduino? Like Arduino is an open source platform which can be used to manage your hardware and software. Okay, so what are the inputs we take from the Arduino? So the inputs are like sensors from where we can take the input, and the output, it can be like your motor, activating the motor, turning on the LED, displaying messages. So these are the outputs which we get from an Arduino board. Now it is composed of two things. One is the hardware, that is our Arduino board, which is having the microcontroller, analog pins, DC jack. So these are my Arduino board, which you can see in the screen itself. And coming to the software part, we have Arduino IDE, which is the Arduino Integrated Development Environment Board, which is the piece of software that runs in our computer. So there are two things, again, like hardware and the software part. So it is freely available, like the software which is we can download from the Arduino web page itself. You have the Windows and Linux also, the version for it. So you can download it and go through this. The hardware board which we need to purchase from outside, and the software, it is available for free. So next we have Raspberry Pi. So the Raspberry Pi can also be used to control different applications of robot and any other things. So here in that, it is a motherboard which contains like USB port, audio jack, Ethernet port, all these different slots are available. So you can just, it will act as a desktop computer if you just plug into your TV or keyboard, and it will be acting as a computer itself. Now the default language which the Raspberry Pi uses is Python, and Python, it also can be downloaded. It's a free software which is available. So you can download it and work on Raspberry Pi. Now next, coming to the Node MCU. Node MCU is Node microcontroller, which is also an open source platform, and you have Arduino an add-on feature on that where you have the built-in Wi-Fi in it. It is a very low cost device which is available, and you have USB port also in that. So if you go on this web page, you can have the things like install ESP8266 add-on Arduino feature, and you can download it and work on its progress. The main advantage of this is you have an inbuilt Wi-Fi in that, so you can use on different applications to control the different applications. So here are some applications of the controller, like you can use for pick and place thing, for the robot to move, and different applications of this controller. So coming to the DRL part, you can use this any of these controllers to control your both the robots. Now next thing is my actuator. So what is an actuator? Actuator is a component of machine that is responsible for moving and controlling a mechanism or a system. So everybody are aware, what I feel is, what is an actuator. You have studied till now, like we can use DC motor, we have servo motor, we have stepper motor in electrical actuator. Now we have pneumatic and hydraulic as well. So what is a motor? A motor is a device that converts the electrical energy into different form of rotational energy. So we have DC motor, VLDC motor, servo motor, and stepper motor. So now DC motor, it is an electrical machine that converts an electrical energy to mechanical energy. So in this, you can find that there are brushes present in the DC motor. This is a motor driver which is used to control the DC motor with the help of your Arduino. So using Arduino, we can control the speed, the action of the DC motor. So LN289 is a motor driver you can use for DC motor. Coming to the brushless motor, that means brushless DC motor. So we don't have any brushes in it present, and it can be very useful in your robotics and application purpose. So in details you have studied, or if you have any queries, you can ask us. I'm not going in detail of that. So again, we have servo motor. Servo motor can be used to turn in any actions like 180 degree or 360 degree. You have different degrees of rotation and can be used in the purpose of servo motor. Next, coming to stepper motor, it can be used in different applications of your robotic arm or CNC machines, camera lenses. So the stepper motor is like, it is also a brushless DC electric motor that divides the rotation in steps. So wherever we need the steps of rotation, we can use the stepper motor. So it will convert your each pulse of electricity into one step. So this is a stepper motor. So here is a GIF application of stepper motor and servo motor, you can see. Now next is our sensors. So we all are aware of the sensors. What are sensors? Sensors is a device which responds to whatever action we take, like whatever the input which we get from the physical environment, and according to this, the sensors act. So the input can be your light, heat, motion, pressure, and any other of the environmental phenomenon. So we have the IR sensor, ultrasonic sensor, LM35, the temperature sensor, the PIR sensor, the smoke sensor. Different types of sensors are used. So on the basis of our application, we can use different types of sensors. So here I'm telling about few of them, like infrared sensor. What is the infrared sensor? It is an electronic device that emits lights in order to sense some object of the surroundings. So there is an emitter and a receiver. So it will emit the light and detect the object, and it receives it back. So it can be used in different applications like sorting devices, object detection, and various robotic applications. Coming to the ultrasonic sensor can also be used to measure the distance and the velocity of an object. For example, to detect where the object is lying, we can use this ultrasonic sensor. It can be used in various applications like anti-collision detection, easy to control vehicles. For example, if the vehicle is moving or your robot is moving in any direction, it can detect very easily that there is some edge or something like that. Okay, so the application, the advantages is very easy to use, and it is very inexpensive. It can be easily available. Now, accelerometer can also be used as a sensor, for the moving rotation. In this purpose, we can use the accelerometer. So it is also readily available. So it is also another type of electronic sensor which we can use in different robotic applications. So in order to design, we can use Tinkercad as a free software where we can use the Tinker for circuit design. For example, if you want to control the speed of the motor, we can use, here is a small video where you can see the application of the motor, how it rotates, and you can see that there is a potentiometer. So with the application of potentiometer, you can use or control the motor. So Tinkercad is a freely available online software which you can use for different circuit connections as well. We can see the different components available in the component list. You can take it and use it back. So here we have another sensor, an Arduino, to use the PIR sensor, which detects the motion of an object. For example, if the object comes nearer, we can see that the LED starts glowing. So these are the different applications of the sensor. which we can use in using the Tinkercad software. You can write the code here itself and you can see the applications of that.